Good afternoon and welcome to At Yale Live. I'm Eric Gershon. Today we talk chemistry, climate, and science policy with Paul Anastas, director of Yale's Center for Green Chemistry and Green Engineering. Often called the father of green chemistry, he has served in a series of high-level federal science policy posts, most recently as assistant administrator of the U.S. EPA, where he led research. In the White House Office of Science and Technology Policy, he was assistant director for the environment. As always, we'll take some of your questions, tweet us at Yale, or email us at socialmedia@yale.edu. Paul Anastas, thanks for being with us.
It's my pleasure. Thanks for having me.
My pleasure. I'd like to ask you a question first about an essay that you wrote as a schoolboy, I gather, that somehow or other was noticed by the administration of Richard Nixon. Tell us that story. About what was the essay about, and do you have any idea how the Nixon administration came to know about it?
That's a true story. That's funny because so I grew up in Quincy, Massachusetts. It's a small town right south of Boston, and I was overlooking this beautiful wetland, teeming with wildlife, all kinds of birds and things, until the bulldozers rolled in. And the bulldozers rolled in, and now if you go up to where I was born, you'll see nothing but glass buildings of banks and insurance companies. So I was furious, and I, among other things, I wrote this essay because the EPA had just been founded, and they were trying to popularize it and get attention. And so I wrote that essay as part of an essay contest, never thinking that I was going to be receiving some kind of recognition from Richard Nixon.
That's who. Do you still have it?
Oh, it's on my wall. If you go to my office here at Yale, you will see my plaque from Richard Nixon when I was 8 years old.
So you went on, you became a scientist. You're often called the father of green chemistry. How did the term come about, and what is green chemistry?
So I'm very proud to be part of a worldwide community of folks that are doing green chemistry. The term, people think I'm joking when they say, how did you come up with this term green chemistry? Because back 20 years ago, not everything was green this and green that. But green conjures up images of the environment and the natural world. But in the US, it's also the color of our money. And so really what green chemistry is about is how do you meet all of the goals of making things healthier for people and the planet, while at the same time meeting your economic goals and aligning those rather than having them work at cross purposes as we've done for so long.
Say more.
So green chemistry looks at the world recognizing that everything that we see, touch, and feel is a chemical. Everything that's the basis of our society and our economy is made from a chemical. And so when we look at all of the positive that chemistry has done, revolutionized medicine, revolutionized agriculture, communications, that cannot be dismissed. But it also has to be recognized that we did it with a lot of unintended consequences. We have to recognize that there's been disasters, Love Canal, what we're doing with climate change, as we'll talk about today, what we're doing even far more recently with the tragedy in West Virginia and the contamination of water. So green chemistry is simply saying we can do better. That in the same way that we'd never accept a beautiful building if it collapsed, would never accept a delicious meal if it was poisonous, there's no reason that we should accept the kind of behavior of chemicals if they provide wonderful function, but they cause toxicity and harm.
There's, as I understand it, sort of 12 core principles of green chemistry. Is there a way to distill those 12 to one fundamental principle?
Yeah, the 12 principles go across the entire life cycle of a chemical, from its feedstocks to what it does during use and end of life. But really, if you distill it down to one statement, it's design your products and your processes so that they reduce or eliminate hazards to human health and the environment. That's it, looking at the intrinsic hazard.
How can green chemistry be used? How is it being used? How might it be used to help us address climate change? Is is it mitigating climate change? And if not yet, how could it?
Yeah, absolutely. So across a wide spectrum, green chemistry is being applied to problems that are directly relevant to climate change. So you obviously would start with alternative energies. Alternative energies that are non-fossil based would be the key way that green chemistry is addressing them. I'd have to say right here at Yale, we have the Yale Energy Institute, and some of the work there and even in my own labs is looking at how you can split water to produce hydrogen as an energy source and in the process generate water back as a byproduct. There's ways of looking at renewables, new generation biodiesel. All of these are directly related to green chemistry and require chemistry in order to do this. There's also a key area that's always been part of chemistry that's now being looked at, and that is catalysis. Catalysis is using a very small amount of a substance to make things happen faster, with less waste, and this has resulted in energy efficiencies across every sector of our economy. So, yeah, green chemistry and climate change are, I would say, inextricably linked.
Science policy question. You spent a lot of time in Washington in various capacities,
Yeah.
And not so long ago. Do you think that the science community could have done better to convince policymakers and the public of the significant threat climate change poses to civilization sooner? And how might the science community have done that?
Yeah. So absolutely. I think that when we look at any of the great grand challenges that we're facing around sustainability, climate change being at the forefront, communication is a tremendous challenge. Now, the first chemist that I'm aware of to raise a flag on climate change was probably Arrhenius back in 1896. And so it's not that it hasn't been known that increasing CO2 levels are going to cause these types of effects. But the ability to communicate, the ability to make compelling cases and languages that people can understand, whether it's the public, whether it's policymakers, I think is a tremendous responsibility of the scientific community, and one that hasn't been as embraced and engaged as it needs to be. You need to speak the language of the tribe you're talking to. And if you need to convince policymakers, then having a scientific definition of the word uncertainty and a popular version of the word uncertainty, that can and is causing so much difficulty in communication.
You obviously get that because you've just articulated it nicely. Do you have the sense that the other scientists working in science policy positions in Washington are really internalizing that and improving at that?
No, I'd suggest that maybe there's been a bit of historical, it's not my job. My job is to generate the data, is to seek the truth, and it's not my job to communicate or translate. I think that the scientific community writ large is learning the lessons and in some cases reaping the bitter fruit of that lack of emphasis on communication. So there's communicating factual observations is not the same as becoming a subjective advocate. No scientist wants to become a subjective advocate. Objectivity is absolutely essential. But being able to communicate that objectivity, it's my perspective that that's absolutely essential.
Slightly different take on a similar question. What is your view of the relationship between science and government policy? That is, they don't always seem to be in sync.
Right. So when you look at the fundamental science that's generated, the data that's generated, that is core foundational to the scientific endeavor, right? But then you start saying, how do we put this in the context of the role of government in trying to help individuals, help society, and all of a sudden you have a lot of factors. You want to make sure that when that decision process is being made and of taking science and turning it into policy, that it's not that it's being done with some consistency. And so you generate policies, protocols for how you use the science. Getting those protocols for how you turn science into policy takes time and approval and goes through many hurdles. In that time, science is not standing still. So many of the protocols you're using to form the policy are no longer using the most up-to-date science. This is something that we need to address, recognize, and resolve. But it's that conflict between science and policy in this area of science policy is a great challenge.
I'm going to take a question from a viewer. This question comes from Mark Johnson, who tweeted it at us. He asks, should we change policy to disaster mediation from fossil fuel substitutes?
So when you look at the current state of affairs with regard to climate change, I'm thinking that most folks realize that we are no longer talking about avoiding the effects of climate change. Climate change is here. We are going to have effects, and I can understand why the question is phrased, and do we simply engage in disaster mitigation? But I think actually John Holdren, who is the president's science advisor, said it best. We have to manage the unavoidable and avoid the unmanageable. So it's absolutely true that we need to be thinking about adaptation. And President Obama, 2 or 3 days ago, just announced a fund, proposed a fund for climate adaptation. But I think it's equally important that if we're going to avoid the worst types of consequences of climate change, then we absolutely still need to take every action available to us currently.
Another question, this one by Facebook from David Kim, who asks, will energy consumption impact America as a viable threat in the next 10 years?
Will our energy consumption?
Will energy consumption impact America as a viable threat in the next 10 years? Which it sounds to me like is a question about the way we're consuming energy now and whether we need to change it ASAP.
Yeah, I have to say that I'm probably a little bit of a heretic in these discussions because we are really not discussing whether or not we want to minimize energy use. We're surrounded by energy. We're swimming in energy. All that we have in this world, in this universe, is energy and matter. What we're talking about is not minimizing all energy. That's really an impossibility. We're talking about the nature of the energy. So when we start selecting the inherent nature, is it going to be renewable or is it going to be depleting? Is it going to be mined or is it going to be harvested, whether it's harvested from the sun or from the ground? So I'd say that I'm all for using potentially even more energy as long as the nature of that energy is inherently more sustainable.
So to follow up on that question, I think it was just yesterday that President Obama announced that he's asked the EPA to draw up new, tighter standards for fuel efficiency for really big trucks.
Right.
So what would your take on that be?
Oh, it's a very important step. It's part of the progression where there's been addressing off-road vehicles. Then there's the current process of addressing various power plants that's ongoing. Even though these large vehicles make up a relatively small percentage of the vehicles on the road, I think it's 4 or 5% of the vehicles on the road, they have the energy demand and the impacts of about 50% of all vehicle traffic. So taking on that very large issue, I think, is absolutely essential and part of a strategy that I think is being rolled out.
A lot of the conversation about climate change and a lot of the research seems to focus on carbon dioxide. And there are good reasons and obvious reasons for that. But it's not the only greenhouse gas.
Right.
Can you talk a little bit about some of the other greenhouse gases, perhaps methane, that are also a serious threat, and how we can address some of those?
Certainly. So when you look at some of the greenhouse gases, CO2 is obviously first and foremost simply because of volume. The volume that's being pumped into the atmosphere is, when you have a gigaton type of issue, that tends to be the headline. But you're absolutely right. So when you look at our history of CFCs, CFCs and different
CFCs,
halogens.
would you define that? Just
Oh, certainly.
Yeah.
Chlorofluorocarbons, which are used as propellants. They could be used as fire extinguishing agents, which were being phased out a number of years ago under the Montreal Protocol. They could have a potency as a greenhouse gas 10,000 times or more that of CO2. You mentioned methane. That is a much more potent greenhouse gas, but you also have to weigh how long is it going to stay in the atmosphere. CO2 might build up for a century or more, where the lifetime of methane is more potent but a shorter lifetime. So when we start talking about energy shifts to methane due to fracking and things like that, you need to know, is that going to cause a short-term spike in our global climate change concerns?
besides methane, others?
Yeah, so the halons, some of the people might remember the old Nike sneakers. They were called Nike Airs. Well, the little bubble in Nike Air, that wasn't filled with air. So that halon was actually one that had a greenhouse gas 26,000 times more potent than
CO2 or
than CO2.
Yeah.
Than CO2. And of course, that was phased out by a wonderful green chemist invention by a person named Richard Wool at the University of Delaware, and now it actually is air in the Nike Airs. But even such things as water vapor. The reason why so many of the concerns for greenhouse gases, the role of clouds, the role of water vapor in so many of our models is not straightforward. It makes it complex.
I'm going to ask you a question about some work you're doing here at Yale. You are the director and founder, or one of the founders of the Center for Green Chemistry and Green Engineering here at Yale. Yeah. Just give us a quick overview of the center and some of the projects that you're most interested in right now.
Great. Yeah. So the Center for Green Chemistry and Green Engineering here at Yale is focused on not on just simply measuring, monitoring, reviewing, or assessing environmental problems. It's saying, what is the and therefore? Okay, we have all of these challenges, and therefore what do we do about it? So it's really an innovation center. So we're doing fundamental research across the School of Forestry and Environmental Studies, the Chemistry Department, the School of Engineering, but it doesn't end there. The center has partnerships and programs with the School of Law, the School of Management, the School of Public Health, the School of Divinity. Why? Because it's not simply about doing basic research. It's about having those discoveries, having that awareness, and translating it into products and processes so that those will either be new companies, new technologies that will be spun out. So one of the early companies that was spun out is something called P2 Sciences that's right here in New Haven. It makes renewable specialty chemicals, everything from flavors and fragrances. And it's really, I don't even want to call it a startup. It's an emerging company that's there. And we're also spinning up things around lignin technology and catalyst technology. Some of our work will also inform next generation curriculum. How does it teach the next generation of scientists and engineers? Some of it might affect policy. But the whole point is that it's not enough to simply have some scientific result, submit it to a journal, and let it be read by the scientist. We need to strive to make sure that it has an impact.
You mentioned the Divinity School. I'm very curious about that. What is what are you doing with the divinity school?
So when we're talking about sustainable technologies, everybody recognizes that it's not enough to just have a technological solution, that if you're going to install this, whether it's in rural America and the developing world, that you're going to want to make sure that that technology, maybe it's around water purification or alternative energy, is socially, culturally appropriate. And so dealing with those issues, we have some wonderful partners who I think the world of at the Divinity School. It's Mary Evelyn Tucker and John Grimm, who are just tremendously thoughtful in this area. Yeah.
To what extent has green chemistry become mainstream? If it has, and if it hasn't, what's it going to take to make it mainstream? What's it going to take for green chemistry to not be an alternative chemistry, but the only acceptable chemistry?
Yeah, no, that's a great way of phrasing it, because I always say that we'll know when green chemistry was successful when the term green chemistry goes away, because when that's simply the way that we always do chemistry. But so I say that there's good news and then there's better news.
Okay.
So the good news is that there are networks of green chemistry research and industry in somewhere around 35 countries around the world. I couldn't even begin to name all of the companies that are incorporating green chemistry, or the schools that are teaching green chemistry. That's the good news. The better news, from my perspective, is all of that activity and all of that research, science, industry represents perhaps 1% of the power and the potential of green chemistry. So when a Wall Street analyst, Pike Research, comes out and puts out a report saying that green chemistry is expected to go to a $100 billion industry by 2020, I think that that's fantastic. But I think that it really touches every sector.
Question from a viewer, this by email from Neil Burns, who asks, and to some extent you've addressed this question, but can you cite some chemistry-based companies that are doing interesting things?
Yeah.
Not just interesting things, but things that you think are the right things.
Yeah. So that's the issue. We see innovation out there all the time, and I think innovation is really at the core, heart, and soul of what green chemistry is all about. It's not about making things less bad. It's how do you design things to be good. So when I think of companies, I mentioned P2 Science, and that's a company that has green chemistry in its DNA. It's not only making superior products, but it's trying to make products also in a superior way. And so you look at this whole growing industry, the bio-based economy, renewable and specialty chemicals. I think that there's just tremendous innovation out there right now.
Back to government for a second. You have a long history with the Environmental Protection Agency.
And I have to say, being named by President Obama to the EPA was the greatest professional honor of my career. It was really quite quite an honor to work with the folks down there, because you think about all of the stereotypes of government workers. Yeah. I just don't know of more dedicated, hardworking people. It was fantastic.
I can imagine.
Yeah.
So you have lived in the belly of the beast of the science policy universe in the United States. Is there a federal agency that you think is, whatever its mission, in the best position to actually have really meaningful, noticeable, within our lifetimes effects on climate change? Is it the EPA, or is it the Department of Energy, or is it NASA? Is it the military?
Right. So the short answer is all of those agencies and far more are all parts of the solution, can be parts of the solution. What's more perhaps important is that because of their legally defined missions, they're currently only pieces, and they're fragmented. And whenever we've run the experiment where you approach problems in a fragmented way, you're going to wind up with unintended consequences. So DOE has a certain mission. EPA has a certain mission. What we did while I was down in Washington is there's something called the National Science and Technology Council that is ostensibly run by President Obama and actively chaired by his science advisor, pulling together all of the agencies around a committee called the Committee on Environment, Natural Resources, and Sustainability, so that you had the National Oceanic and Atmospheric Administration together with the National Institutes of Health, with EPA, with FDA, with USDA, all of the different pieces, so that you start getting alignment, so that you start getting integrative systems thinking. That is what's likely necessary in order to get the drivers moving in the right direction.
I'm going to take another question, this by email from Vahe Marganian, who asks about methane, and it sounds like would like you to elaborate a little bit. Why is methane such a potent greenhouse gas? And are we most concerned with human-made sources of it or natural sources of it?
So methane is methane. It's a carbon with 4 hydrogens, and it really doesn't care whether it came from a natural source or a man-made source. And so when we start thinking about methane as a greenhouse gas and why it's so potent, it's potent for the same reasons that CO2 is, and it all has to do with the chemical bonds. When you're having the activation energy, which stretches the bonds of the carbon and the hydrogen, or in the case of CO2, the carbon and the oxygen, that's what makes something a greenhouse gas. And if something does it more effectively than another, it's a more potent greenhouse gas. So the ranking of all of these gases is basically an intrinsic property of those molecules. So there are absolutely natural sources, whether it's marshes or the melting tundra or other natural sources. But what we're seeing is, with the growth in methane as a fuel source, with some of the latest developments in fracking, there's a lot of effort to focus on how much of this is becoming fugitive emissions and creating higher concentrations of methane in the environment. And whether or not that's leaky or tight, that system is going to be very consequential for near-term climate change.
We've talked a fair amount about government's role in climate change and the way that it might be done differently and perhaps better. There are individuals now who are getting very serious about climate change. You may have seen a story in the New York Times, I think it was yesterday, about Tom Steyer, a San Francisco billionaire, who has taken a serious interest in climate change and is investing heavily in it. The Times reported that he may spend as much as $100 million trying to influence elections in order to back candidates who he thinks will crack down on activities that are leading to climate change. How, in your view, can someone like Tom Steyer be effective?
So I guess more than anything else, I come at most of these issues of whether it's climate change or sustainability generally from the perspective that innovation is going to be necessary in order to change the trajectory that we're on. So how do we get that ecosystem that is necessary in order to facilitate innovation? So if we try to make things just a little bit more efficient, a little bit less bad, that's not going to get us off our climate change trajectory. That's not going to get us off our unsustainable trajectory that we're on. We need game-changing innovations, which is why I'm so excited about this whole maker movement, this whole idea that people can invent, people can innovate. And when we look right here at Yale, at the new Center for Engineering and Innovation Design, where students are making and creating, or this is happening around the U.S., around the world. So people who are interested in changing what the future looks like, I'd suggest that they be involved in enabling designing the future to look differently than it does today, because largely tomorrow is going to look like what we design it to look like.
Question by email from Elizabeth Grossman, who asks, is a policy that does not include any requirement for inherently safer technology going to adequately prevent incidents such as the Freedom Industries spill in West Virginia?
Yeah, the spill in West Virginia is an absolute tragedy, and it's an ongoing tragedy, and it's a shame that it makes a few headlines and then goes away when so many people can't drink their water. So we've had, let's call it between 40 and 50 years of environmental policies that try to control exposure, set standards about, quite frankly, how bad you can be, how much you can pollute and still not be breaking the law. That is an important step to set a floor of how egregious you can be. But it's half a strategy. The other strategy has to be creating a race to the top. So the questioner is asking about, can we pursue inherently safer technology? Well, that's what green chemistry has been showing over the past 20 years. Green chemistry and green engineering are showing that you don't have to compromise on performance. You can have exceptional performance and still make sure that it's inherently safer, inherently less polluting. So I completely agree that there's a lack of awareness what's possible, but those possibilities for inherently safer design, sustainable technologies need to be built into our policies, into our laws.
I wonder, I don't know if I've asked this, and maybe you've answered it in response to another question, but can you cite a few examples of green chemistry at work, that is, green chemistry successfully done, the way you want to see it done, the way it should be done?
Yeah, certainly. When we talk about a lot of these bio-based products that look across the life cycle on how they're not only less toxic but renewable on the front end and degradable at the back end, those are a whole class of products. When we look at the area of catalysis that we mentioned earlier, so we could say that it uses lower energy, causes less waste, uses less material, and at the same time, it's so economically profitable that there wouldn't be a chemical or petrochemical company in business without using catalysis. So it's infused in so many different places of where you can show that green chemistry is causing sustainability and profitability at the same time. The problem is it's not systematic yet. We have countless anecdotes, but what we need to have this be is the default value for how we make our products and processes.
I wonder if you could talk to us a little bit about what it's like to have to manage or be part of the response to a major environmental disaster. And I'm thinking of the BP oil spill, which, and correct me if I'm wrong, occurred during your most recent stint at EPA.
Yeah, it was it's certainly a tragedy. The BP oil spill was happened while I was there. Fukushima also happened while I was there. The Fukushima meltdown of the nuclear reactors. What is interesting is that when we are dealing with tragedies, crises, that we think it just natural that what we do is we call together all the different types of folks around a table. You usually have some kind of nerve center where you react to these things, and so you'll have the scientists and the engineers together with the policymakers, the communication specialists, the lawyers. Everyone's around the table, all hands on deck, because you need all of those different parts. That happened in the BP oil spill, all hands on deck. It happened with Fukushima. We created these nerve centers. I think one of the lessons that comes out of these reactions, which, thank goodness for the reactions, because I think that those tragedies, as bad as they were, could have been even worse, is that gathering folks together in a crisis is important. But what if your crisis is happening in slow motion? So we're seeing a lot of these challenges of sustainability, whether it's our water quality and quantity depletion, with California showing a drought that is just
historic,
right, and Australia just emerging from one. Whether we're looking at the climate change crisis, these are crises happening in slow motion, biodiversity depletion. And we go through these different issues. The same type of transdisciplinary, integrative thinking, where you bring together all the different perspectives, all the different skill sets, is just as essential to addressing these problems that happen in slow motion as they are with the egregious explosions and meltdowns.
Clearly there are individuals or organizations that are taking climate change very seriously in this country and elsewhere. Do you believe that our society here in the United States is, as a society, taking climate change seriously yet?
The short answer is not seriously enough. The short answer is no. So when we look at the status quo, whether it's with climate change, where we're conducting an uncontrolled experiment on the only atmosphere that we have, whether it's we're talking about chemicals, where we are allowing our products of daily use for individuals, for children, to be contaminated with things that are going to potentially cause cancer, cause reproductive and developmental effects, and somehow that's accepted. These are absurdities, historical absurdities that I believe we will look back on and say, how could we have possibly accepted these things and taken these things in stride? So I believe the status quo is somewhere between an absurdity and an obscenity, that we allow these things to happen. Contamination of our environment, changing and jeopardizing our children's health. So I am a sworn enemy of the status quo, which is why I think innovation and sustainable innovation is the only path forward. So if we look at climate change, it's always viewed as something off in the future, even though we're seeing it happening all around us now. When we look at many of these toxic effects, we think of them as happening to someone else, yet we all know someone who has suffered from them if we ourselves haven't. So yeah, we need to change the status quo, and we need to do it rapidly.
I've been asking most of the questions. The viewers have asked some questions. We're going to wrap it up in just a minute, but I want to give you a chance to sort of offer a parting thought. If there's one thing that you would like to leave the viewers with today about one thought about green chemistry, about the environment, about climate change, about science policy, what is it?
That green chemistry, green engineering, sustainable design, it's all about innovation. It's all about the promise that creativity brings to us. And so, we think that all that we have, and I mentioned earlier, all that we have in this world is energy and matter. That's all we have. Well, the truth of the matter is that's not all we have. We have creativity, we have spirit, we have innovation, we have commitment, we have dedication, and the power and potential of green chemistry, green engineering, sustainable design is to get us off our current trajectory and do it in a way that's going to result in just a far better world.
Paul Anastas, thanks for joining us on At Yale Live, and thanks to all of you for watching At Yale Live. Join us again next time.